Just north of the Martian equator lies a 45-kilometer-wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind: life. On February 18th, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years. Kind of like using your roommate's spice rack. What? I thought you said it was communal. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With the combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into the Jezero crater, we could encounter spores associated with a relatively recent geological era. And on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it. This creates a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board the rover, only a few dozen samples can be collected. So, no pressure and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures on Earth. Biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft and then returned to Earth. Whoa, this looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA. In 1543, Copernicus boldly shook the status quo with his theory that the planets orbited the sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is the Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecrafts from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life. But another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens. Mind you, it's possible that life on Mars didn't have the right conditions to start at all. Or maybe it died off from an extinction event, similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. Venus, one of the most fascinating and dangerous planets in our solar system. It's filled with scorching temperatures, crushing atmospheric pressure, and acid rain. But despite these dangers, some people think it might be a better planet for humans to settle on than Mars. But why? And would a human settlement on Venus even be possible? Sit back as we take you on a 10,000-day journey of how humanity could populate this planet. Yeah, maybe. Day 1. Okay, not so fast. Before you set foot on Venus, we're going to have to run some extensive tests and gather more information about this planet. First, we'll need to launch robotic missions and map it out and collect information about the environment. Luckily, we already have a bit of a head start on this. Since 1961, spacecraft have been flying by and profiling Venus. These missions measured things like the topography, atmospheric pressure, and the overall conditions of the planet. But there's still a lot to learn about the Venusian surface.
It's been 30 years since the US has gone to Venus with a mission.
That's Noam Eisenberg. He works for the Venus Exploration Analysis Group, a NASA community whose goal is to keep people updated on new information about Venus. In the 2020s and 2030s, Noam will be part of a satellite mission to Venus to help us understand and see more of the planet than ever before. But today, Noam's going to help us determine whether or not colonizing Venus is a good idea.
You have to wear one or the other of several different science fiction hats in order to make this happen.
Okay, let's put our hypothetical science fiction hats to the test and get started. Day 500. We've been trying to colonize Venus for a little over a year now, and the results have been, well... There's been a bit of trial and error going on with our astronauts. They keep going out to explore the surface of Venus, but keep dying. Why?
So it's not clear that if you were immediately transported there, whether you would burn to death or crush to death first. But certainly both of those things would happen before you asphyxiated in the carbon dioxide atmosphere.
Right. Well, we probably should have listened to Noam a bit closer, because it turns out the Venusian surface is incredibly dangerous. 3 reasons why. Venus has one of the hottest surface temperatures of any planet, even Mercury. The surface temperatures reach 467 degrees Celsius. That's hot enough to melt lead, or some unsuspecting astronauts. But let's say we somehow manage to build super heat-resistant astronaut suits. Well, you'd still be met with incredible pressure. The atmospheric pressure on Venus is equivalent to what you'd experience at a depth of 900 meters underwater. This would instantly crush any astronaut. It would also crush and destroy your spaceship as you land. And if you manage to avoid all that, which you won't, but let's say you do, you'll also have to deal with a corrosive atmosphere and acid rain. These conditions are powerful enough to destroy your equipment and eventually melt your skin. Okay, I don't think this is gonna work out. Let's jump ahead and try to terraform Venus to make it more like Earth. Day 1000. So, we've been attempting to terraform Venus, and it's been a pretty tricky process. The first problem we'd need to solve would be the atmosphere. To make it similar to what we have on Earth, we'd need to eliminate the carbon dioxide and sulfuric clouds. In theory, we could introduce genetically engineered microorganisms that absorb carbon dioxide. But then there's the scorching temperature on Venus. Now, solving this could be done in multiple ways. One of them involves setting up solar shades in space. This would redirect the sun's rays so they don't hit Venus, which would reduce the solar radiation and cool the planet over time. This all sounds wicked cool from a science fiction perspective, but realistically, we're a couple hundred or thousands of years too early for any of this to be possible. Okay, this is really complicated. Noam, any ideas?
The only way we could inhabit the surface of Venus is if we changed Venus to be much more Earth-like than it is. And right now, we don't have that technology. We don't have that ability. We don't have the resources. If we could terraform Venus, it'd be much, much easier to sort of re-terraform Earth and undo all the damage we've done here. And I don't even know how you would go about doing that. Think about that as science fiction, science fantasy method, right?
Okay, sounds like we should switch our tactics. If humans were to live on Venus, well, it technically couldn't be on the surface. That would just cost too much money, time, and technology that's not available yet. Maybe it's not about living on the surface, but instead living right above it. Let's fast forward. Day 2500. Okay, after years of experimentation, we've finally found the answer about how to live on Venus. I think. The new plan is to create a cloud city 50 kilometers above Venus's surface. Arguably, this could be one of the most comfortable places for humans to exist in our solar system, besides Earth.
That altitude in the Venus atmosphere is kind of actually the most Earth-like any other place in the solar system is. So in that altitude, the temperature is around, depending on where you are, is somewhere between 20 and 30 degrees Celsius, so it could be shirt sleeve weather. The atmospheric pressure is around 1 bar, half to 1 bar.
So up here in the clouds, it would feel like a nice summer day, and the atmospheric pressure wouldn't crush you. Sounds good to me. But what would you live in exactly? Well, we'd create blimps made of Teflon that could be suspended in the clouds. Each blimp could have a different purpose and have different groups of people within it, all connected with covered bridges so you can travel from one end to the other. We'd also be protected from any harmful solar radiation due to Venus's thick atmosphere. That's something Mars can't provide. But despite us making significant progress, these cloud cities wouldn't be without their shortcomings. Day 5000. Okay, we've been expanding and living in these cloud colonies for over 6 years now. We should also mention that you and your space colleagues have been working a ton. Hey, we never said building a new population on an entirely different planet would be easy. If you're going to be one of the people in charge of colonizing Venus, you can expect non-stop workdays. From researching the planet to just setting things up for your daily life and survival. You'd need to build cloud ships that can provide food through hydroponic gardening, and solar-paneled ships that can provide power. This would require an incredible amount of skill and resources. And oops, I forgot to mention another extremely dangerous thing that you need to be aware of. That's the sulfuric acid clouds. They're going to be tricky to avoid, even being 50 kilometers above the surface. Remember, these things are hazardous and could easily melt your skin. Now, not all areas in this cloud city would have these clouds, luckily.
But if you are living in an area where that sulfuric acid is there, then you're talking about a Kevlar envelope, you're talking about things that you need much more protection from, even if temperature pressure is not the major concern.
And the problems might get even worse as we progress to our next phase in populating Venus. Day 10,000. Okay, we've been populating Venus for nearly 30 years now. Hundreds of astronauts have come and gone. Some have even started having children, creating new generations of native Venusians. You've kept busy maintaining and building these cloud ships while learning more about the planet. But over the decades you've been here, life hasn't been nearly as exciting as you thought it might be.
You spend most of your time in this yellow haze, maybe you get to see some sky and stuff like that, so not necessarily the most romantic or inspirational location. So you're living in a box, and most of your view of the surface will be through, automated ports and stuff like that.
And thanks to the acid clouds, it's likely you wouldn't be able to spend much time outside either.
Not the most comfortable environment to live in either the atmosphere or the surface.
Living in these cloud ships doesn't sound all that great. Sure, you'd be creating a new world for humans to live in, but there wouldn't be much exploring. It would just be going from ship to ship, maintaining them, and getting to research a surface that's 50 kilometers below you. Sounds like a tiring and somewhat sad existence. Would it be worth it?
So for permanent habitation in or on or around Venus, I don't think will happen. I don't think it should happen.
But that doesn't mean our hopes for humans becoming an interstellar civilization are misguided.
But I do think that permanent habitation outside of Earth both should and will happen. I believe that, in the long term, multi-century long term, getting all the eggs out of the one basket, getting all the humans off of Earth is what we need to do as a species in order to ensure our, in perpetuity survival.
So maybe populating Venus isn't the best idea. After all, it's impractical, in many ways impossible, and seems like a sad existence for humans anyway. With all these different planets we'll be populating, electing leaders to run them will be essential. But what's even more important? Electing our leaders right down here on Earth. If you're in the United States, you're probably hearing a lot about the 2024 presidential election, but that's not the only election happening. There are also elections for your state, city, Supreme Court, school board, and more. So don't just vote for the president come November, vote down the ballot. More than you may realize, your local government has a huge impact on your daily life. From public transportation to education to how your tax dollars are spent. Local voting can help bring communities together. Instead of disagreeing on massive national issues, communities can come together to vote for safer streets, better schools, and access to parks. So when you're voting in an election, and I hope you will, remember, it's not just who's at the top of the ballot that counts. Every decision you make has an impact on you and your community. Rockets are incredibly powerful. You can launch yourself into orbit, fly the moon, and soon enough, travel to Mars. But to go beyond our solar system, you're going to need something else. Solar sails. How exactly would sails work out in space? How long would it take you to travel to the edge of the solar system? And why could this journey end with your slow and lonely demise? This is What If, and here's what would happen if you sailed the galaxy on solar winds. To launch a spaceship, you need a rocket to push you up into the sky. That push is called thrust. Being launched from Earth with the power of a rocket gives a spacecraft most of its momentum. After this, you need more fuel to change your speed or course. But there are no gas stations out there in space for you to refuel, and that means you can only go as far as your fuel takes you. You see, more fuel means more weight, and in space, your reserves are limited. In other words, it would be really hard to get to your interstellar destination with rockets alone. But all of that is about to change. All aboard! You're set to sail across the galaxy. On Earth, sails have been moving boats around the globe for centuries. They work without any fuel, only the power of wind. But out in space, there are no air particles moving around, so you'd need to harness a different kind of wind. Solar winds carry charged particles ejected by the sun. These particles fly across the solar system at a blisteringly fast 1.6 million kilometers per hour. But with a special type of sail, you could take advantage of that power to get yourself across the solar system and beyond. And no, those special sails wouldn't look much like the sails you're familiar with. Are you ready to have your mind blown? This is the contraption that could take you across the galaxy. It's called electric sails, or e-sails. They're kind of like an umbrella without fabric, only these ribs would be made of electrically charged aluminum wires, and they can be as long as 20 kilometers, while also being no thicker than about half of one strand of hair upon your head. Now, all you'd need is the solar wind, and you could sail across the deep, dark sea of outer space. Wait. There's one catch. You see, you'd still need chemical rockets to launch you off into space to begin with. That's because electric sails don't work within Earth's magnetosphere. The magnetosphere is the area around the planet that's under the influence of its magnetic field. It's up to 10 times larger than Earth itself. And to escape it, you'd need a little boost from the old school rockets. Or you could build a spaceport around Earth. It would have to be far enough so that the planet's magnetic field doesn't reach it. But that would get too expensive and take too long to construct, and we want to send you on this journey right now. So you'd launch your ship from Earth and out of the magnetosphere's limits. From there, it would be smooth sailing. With a 1,000 kilogram spacecraft like yours, you'd have about 100 wires to catch solar wind particles. You'd be a pioneer voyaging through space with this fantastic new technology. After 1 year of sailing, you'd reach a speed of at least 30 kilometers per second. And you might even go as fast as 150 kilometers per second. Yeah, and that's really fast. Faster than Voyager 1, the fastest space probe humans have ever sent off-world. The Voyager 1 probe is hurtling through space at about 17 kilometers per second. After spending 3 years getting past Mars, Jupiter, Saturn, and Uranus, you'd end up beyond the orbit of Neptune. You'd navigate by simply changing the voltage levels on different wires of your electric sails. Yeah, well, you'd still have to be a navigational genius to sail safely, especially when you get closer to the outer edges of the solar system. Here, you have to pass through the Kuiper Belt. This area is filled with icy comets, and if you're not careful, these comets will do some hefty damage to your electric sails. Yeah, your interstellar trip might end before you even get out of our planetary neighborhood. After that, you've still got a long way to go to the very end of the solar system, the heliopause. It's 4 times further away from the Sun than Neptune. So, fasten your seatbelts and power through a pretty uneventful view for about 10 more years. Yeah, I know, you'd prefer a view of Jupiter or Uranus instead. But hey, it's almost time to explore worlds you've never seen. Ooh, I just remembered I was supposed to tell you something important. Yeah, you know how your electric sails need solar winds to sail? Well, now you'd be the furthest from the Sun you've ever been, and that means there won't be as many solar particles pushing your spaceship forward. Your sailing might just come to a complete stop, leaving you stuck forever in the outskirts of the solar system. Cold, lonely, and hopeless. Yeah, I'm not gonna lie, this could be how your days come to an end. So, while you still have some life left in your sails, you'll need to navigate to another star. If I were you, I'd head to the Alpha Centauri star system. It's the closest one around, and it has not 1 but 3 stars. Now, you should also know that not all stars are equal in providing you the powerful solar winds you so desperately need. Passing by a red dwarf star like Alpha Centauri C, also known as Proxima Centauri, you'd experience luminosities that could be anywhere from 1/10 to 1/10,000th as strong as our own sun. But despite this, you might be able to gain enough accelerating power to reach super high speeds once again. And all this without any chemical fuel. Yeah, going green is the cool new thing everyone's talking about.
What if we humans could live somewhere outside of Earth? Say the moon. Obviously, we can't just pack our stuff and move there today, but what if we terraformed it, reshaped it into Earth's image? How long would it take us to turn our natural satellite into a habitable place? What would this Earth-moon look like? Would this even be possible? This is What If, and here's what would happen if we terraformed the moon. Wondering why we chose the moon and not Mars? With water ice buried beneath its surface, the red planet seems to be the best candidate to serve as our second Earth. But with zero experience terraforming, we should consider colonizing our natural satellite first. It gets twice as much sunlight as Mars, and it's just a 3-day trip from us. In short, it would take us less time and money to construct a decent Earth on our moon. So, how exactly do we engineer a habitable planet? Just to be clear, we're not talking about building a permanent moon base. We'd go nuts and actually transform the moon into an Earth, just a smaller one. For starters, we'd need to build an atmosphere. And here's the fun part. To do that, we'd need to bombard our moon with 100 water ice comets, asteroids. We'd find them flying all around the Earth. These comets would crash into the moon's surface. They'd fill the moon's plains with water and disperse carbon dioxide along with water vapor and a little bit of ammonia and methane. All these gases would gather near the surface, creating an atmosphere. The newly formed seas would reflect much more sunlight, making the moon appear 5 times brighter when seen from Earth. These asteroids would also give the moon a momentum. They'd make our satellite spin close to an Earth-like cycle. The more comets we batter into the moon, the faster it would rotate. A lunar day would drop down from an incredible 28 Earth days to just 60 hours. Since our satellite wouldn't rotate on its axis at the same rate it orbits the Earth anymore, it would no longer be tidally locked to our planet. For Earthers, this would mean we'd be able to see the dark side of the moon, although it wouldn't be dark. But How do we save the newly built lunar atmosphere from being stripped away by solar winds? We'd have a couple of options. The first one is easy. Moon's own rotation would generate a dynamo effect. That dynamo could awaken the Moon's once active magnetic field that would keep the atmosphere in place. If that doesn't work out, we'd have to place a gigantic shield in orbit. That shield would work as an artificial bow shock, making up for a missing magnetic field. When that's all sorted, we'd bring in genetically engineered plants, suitable for growing on the Moon's stony ground. We'd also drop some algae that would release oxygen into the air. That would be the start of life on the Moon. Finally, after many decades of hard and costly work, we'd send the first human colony to settle down on the first man-made planet. The terraformed Moon would get very warm from greenhouse effects. It would be mostly cloudy too, and with tides as high as 20 meters, surfers might want to make the trip. Living on the Moon would be just like living in Florida, but with 1/6 of the Earth's gravity. The Moon settlers would be able to jump as high as 3 meters off the ground, remaining in the air for 4 seconds. And if they were really fit and full of stamina, they'd be able to run across the Moon's lake. This is because running on the water requires less muscle power if you do it in reduced gravity. Would you move to the Moon to experience all that? No human has ever been outside of our solar system, and only a few of us have actually left the Earth. Even those who blasted out of here in a rocket didn't go too far. There are billions upon billions of planets out there, but they're so far away it would take us a very long time to reach them. If we jumped into the fastest spacecraft ever built, it would take us over 70,000 years to get to our neighboring star system, Alpha Centauri. Even if we could accelerate a spaceship to 99% the speed of light, over 26,000 years would pass until we arrived at the center of our own galaxy, and another 2 million years until we set foot in the nearest neighbor, the Andromeda Galaxy. How could we go about expanding our civilization into space if we're so terribly slow? To become an intergalactic civilization, we'd need to break the speed limit of the universe. But for all we know, traveling at light speed is physically impossible, never mind outperforming it. The universe is enormous, possibly infinite, and our lifespans are too miserably short to cover those kind of distances, even at near light speeds. But let your curiosity take over and imagine we were a civilization that could approach light speed and travel among stars. We'd start with Alpha Centauri, our neighboring star system. Who knows, maybe the exoplanet orbiting this 3-star system would turn out to be habitable. Then, we'd push ourselves out further to discover the billions of other worlds. Not all of them would be suitable for us to settle in. In astronomy, a habitable world is a planet that is just the right distance from its sun-like star to be able to sustain liquid water. But the reality is, humans require so much more than that. Atmosphere, gravity, temperature, they're all important. It's unlikely that we'd find another planet just like Earth. But we could build self-sustaining Earth-like biomes on our giant spaceships where humans could live for generations. Or we could terraform some rocky exoplanets. First, we'd harvest water from a few ice comets. Then, we'd alter the planet's atmospheres to resemble Earth's. Anything to be able to breathe in fresh air again. Even though space would be so accessible, people wouldn't travel around the universe much once the new colonies were established. Even at the speed of light, it would take generations to make a trip to the other side of the universe. Space is just too vast, remember? In this new world, you'd get to travel among stars only if you were a part of a ship's crew, a colonist, or a space miner. We'd send robots to perform our intergalactic chores. Robots don't eat, sleep, or go to the bathroom. They can withstand high levels of radiation and extreme temperatures, all the things that would kill a human being. But if space travel is something you crave, consider pursuing a career as a postal carrier, because the most reliable way to communicate might be through the mail. Surprised? Well, our satellites rely on radio waves to transmit information. Even though these waves travel just as fast as light, they lose their strength over long distances. It's like being too far away from your Wi-Fi router. If humanity did become an interstellar society, we humans would end up spread out across hundreds of light years of space. At least we'd give Earth a break and allow it to recover from our mistreatment.
Are you ready for a new start? Are you sick and tired of Earth and all its problems? Well, here's your chance to start fresh by moving to Titan. Yeah, you heard me, Titan. Saturn's largest moon could be your new home away from home. How would we power our new home? What would we eat? And how would we handle crime? This is What If, and here's what would happen if we colonized Titan. Even if you weren't 1.5 billion kilometers away from Earth, starting a community is extremely hard. Luckily for you, we're here to help you work out the kinks. You know, the first thing they teach you in real estate is location, 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 and thankfully, Titan fits the bill. Titan is the most Earth-like place in our solar system because of its thick atmosphere and water on its surface. Of course, there are some differences you're going to have to get used to. Differences like Titan having 1.6 times the atmospheric pressure of Earth. That's the same pressure you'd feel diving about 5 meters down into the ocean. On the plus side, Titan has seasonal changes that would let you rock your new fall getup. And I hope you like it because on Titan, a season lasts about 7 Earth years. The main pull, however, is Titan's abundant supply of hydrocarbons. They could be used to build shelters and for energy sources. Okay, that was a good enough reason for us to set up shop here, but how exactly would we create our community? Well, the first step would be to send a fleet of smart robots to start prepping for human settlers. The robots could start constructing houses, buildings, and mines. Since Titan is filled with hydrocarbons, such as methane and ethane, it makes sense to convert them into plastic and use them as building materials. As for powering the settlement, we'd have to cover about 10% of Titan's surface with solar panels. That's no small feat, but with a little elbow grease and scientific know-how, we could pull it off. Next, it's time to make ourselves at home. But what would life on Titan be like anyway? Well, first, you're going to have to bundle up. The surface temperature on Titan is minus 179 degrees. Translation, it's really cold. We would need to build large domes with self-sustaining ecosystems for us to stay alive. Those self-sustaining ecosystems would provide us with food. We would take the lessons learned from the International Space Station on how to grow lettuce, peas, and radishes. These have all been successfully grown in their space garden and will help us to understand how low gravity affects plants. With less sunlight reaching Titan than our plants are used to, we'd need to add additional lighting to make our galactic greenhouse thrive. But what if vegetables weren't cutting it? What if you had a craving for a juicy, meaty Earth burger? Well, we could use cellular agriculture to grow meat from animal cells in large bioreactors. And for snacks, we could farm insects. Okay, hear me out. Insects are a great source of protein. And farming insects is energy efficient as it doesn't require a lot of farmland, energy, or water. Come on, just try some. So, we could set up our colony and work together in harmony to— Hey! Who stole my cricket sandwich? Like in any society, not everyone is going to play nice. So, what do we do about crime in space? Thankfully, we have a contingency plan. A researcher at the University of California suggested that committing a crime on Mars would be so hard to do that no one would be tempted to try it. The same could be said for our Titan colony. This is because of all the monitoring data that would be needed, such as airlocks opening and closing, exact GPS data about your whereabouts, your vital signs, adrenaline levels, and so on. If someone did commit a crime, all that data would make it pretty easy to identify the criminal. That'll teach you. This is my cricket sandwich. And you don't have to be a rocket scientist to go to Titan. In the beginning, we would need skilled laborers to build it, with engineers, nurses, farmers, and cooks. Much like the way a community on Earth is made up of all kinds of people with different skills, we would need someone like you in our new home on Titan. "635 light years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler-22b. When a planet is located within a star's habitable zone, it means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler-22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler-22b. Kepler-22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler-22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. What did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler-22b using what's called the transit method. They watched Kepler-22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler-22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler-22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler-22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler-22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler-22b could be about 15 to 22 degrees Celsius, similar to Earth's spring weather and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler-22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler-22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because our galaxy is also big enough to include some hope. New studies suggest that Kepler-22b might be covered in an ocean 50 meters deep, and that ocean would be able to act as natural climate control, keeping the wild temperatures at bay. You see, an ocean can store heat in the summer and release it during the winter, which results in a mild climate. Like you needed another reason to live close to the water. But hold on, how would you even make it all the way to Kepler-22b? I mean, even if you were traveling at the speed of light, it would take you 635 years. Your best bet could be to hibernate through the trip inside a device that preserves your body way past its natural lifespan, like cryogenic sleep. NASA has already developed a cryosleep chamber that can lower an astronaut's body temperature to as low as 32 degrees Celsius. This would trigger natural hibernation, during which catheters would provide your body with nutrients and remove any waste. But even in cryosleep, it would be quite the long, risky trip. This leads us to the most dangerous part about this journey. All that remains unknown about Kepler-22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler-22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of light-speed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler-22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler-22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be entirely covered with water. If you and the other first settlers woke up from your cryosleep and found yourself on a gas planet, yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler-22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler-22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity.
Martians might really exist in the future.
But instead of the aliens of sci-fi movies, Martians would be humans, born and raised on Mars. And in this episode, you're one of them. Why would your skin be orange? Would you be a different species? And would you ever be able to visit Earth? This is What If, and here's what would happen if you were born on Mars. Some of our previous episodes have already looked at what it would take to live on Mars, but that's only half the story. To create a stable settlement on the red planet, people would have to start having babies. How many people would we need to create a healthy, non-inbred population? Well, some say we'd only need 98 people, but others say we'd need a minimum of 10,000. But regardless of the size of the breeding population, it would only take a few generations before we started seeing a huge difference between Earthlings and Martians. Mars is the most Earth-like planet in the solar system, but it's not exactly like the Earth. Its gravity, atmosphere, and magnetic field would create serious challenges for human life. And challenges often go hand in hand with evolution. Children on Earth are born with up to 120 genetic mutations. Move those babies to Mars, and they would start having mutations suitable for Martian living. And those mutations would likely pass on to their children. By the time we settle on Mars, we'll probably have the ability to modify our own genes, putting Martian evolution on the fast track. So, if you were born in the third or fourth generation of Martians, you would be a lot different than you are today. But what are the main reasons why your body would change? Well, first, there's gravity. Mars only has 1/3 of Earth's gravity, so your bones wouldn't experience the same force. Your bones would lose their density and become more brittle. Breaking them would become a common issue. Then there's the atmosphere. On Earth, you're used to a dense atmosphere that mostly contains nitrogen and oxygen, but on Mars, you'd be experiencing a thin atmosphere that's mostly carbon dioxide with only trace amounts of oxygen. You wouldn't be able to evolve a whole new respiratory system, but you could develop other ways of dealing with the lack of oxygen. Like you could have denser capillaries that are more efficient at moving blood and transporting oxygen to your muscles. But even with these advances, you'd still have to live underground or in a thickly insulated house to survive the harsh atmosphere. And since life on Mars would be confined to small spaces, Martians wouldn't need to be able to see far into the distance. Yeah, you would be born nearsighted. And finally, there's the radiation. Earth has a strong magnetic field that protects us from lethal solar radiation, but Mars has a weak magnetic field that's scattered along the planet. On Earth, our bodies produce melanin. It protects us from the radiation that does make it through Earth's magnetic field, but the radiation on Mars would be much stronger, and melanin just wouldn't cut it. Instead, your skin would produce carotenoids. This pigment would help protect you against skin cancer by slowing or stopping the cell cycle. Carotenoids can even make melanoma cells self-destruct. They're also what gives carrots their vivid orange coloring. Yeah, in other words, your skin would be orange. So, with all these changes to your body, would you be able to visit Earth? Well, Mars wouldn't have the same type of bacteria and viruses that the Earth does. So your immune system would be weaker than that of an Earthling's, which means Earth could be a dangerous place for you. And even if your immune system were strong, the gravity of Earth would be too much for your brittle bones. If you were born on Mars, you'd probably have to stay there. Humans have looked the same for a very long time, but within a few generations of living on Mars, we could have orange, nearsighted humans who could survive on less oxygen. And once we successfully settle on Mars, we probably wouldn't stop there. In the future, humans could have settlements on all sorts of planets, even outside the solar system. You know, What if all aliens, whom we're so excited and terrified to meet, are just future versions of humans? Well, that's a story for another What If.